Okay, I'm going to give you some hints going over your Unit 5 review for Algebra 2. Use this while you're working at home to make sure you're ready for your test next class. When you are graphing, first thing you want to figure out is whether it is exponential or logarithmic. So this one here is exponential, so it's number 4, whereas 5 and 6 are both logs. You want to find your asymptotes for either. Remember, for exponentials, you have a horizontal asymptote, and it is always at your k value. So here it would be at -6, and you would draw that asymptote in. That gives you the bottom of your graph to help you kind of base where your numbers should be at. Think about whether it's growth or decay. So this 3 is bigger than 1. So this is a growth function. It should go up to the right. Number 4 is a decay function, so it should be going down to the right. When you make your t-chart for exponential functions, you're going to find your h value, which means you take your number near your x and switch its sign, and we use that to center our graph. So we're going to do -1, -2, -3, and 0 and 1. You will plug those in, and your graph, again, should look approximately like this. You're going to fill in your chart. Remember to use the answer key to go over your chart answers of everything it should be. When you are finding an x-intercept, remember that you are taking your function and setting it equal to 0. When you are finding your y-intercept, you are plugging in 0. So this part of your chart is actually going to directly give you your y-intercept. You can always just plug in 0 to get that. Looking at your log function, these switch a little bit because remember it's the inverse of your exponential. Now instead of having a horizontal asymptote, you have a vertical asymptote, and it is always at x equals your h value. It is important to notice whether your h or whether the number added or subtracted here is in parentheses or not. So the one in parentheses is your h. The one outside of your parentheses is your k. So like on number 6, this 4, x plus 4 is my h, so my vertical asymptote is at x equals -4. Again, you switch your sign. Whereas on number 5, this 3 is your k value, so that means my vertical asymptote is at 0. Since there's no h, it's 0. When you make your chart, your vertical asymptote tells you where your graph will be. It will be on the right of your asymptote. So I'm not going to plug in any points that are on the left, so we'll start at 0. And again, on number 6, you will start at -4. When you're going to ones through 7 through 14, you are rewriting. So for example, on number 7, this would be log base 8 of 64 equals 2. On ones like 11 through 13, you're going the other way. On number 14, remember to fill in your base. That's log base e. So this would be e to the 38th equals x. This is an important skill for solving equations, being able to go back and forth. So make sure that you play with that. On 15 through 22, you are evaluating these logs. These first 4 you should be able to do in your head. So try doing them without a calculator. You do not need a calculator for these. 19 through 22, however, you need your change of base because if you think back to what we did before, you would set this equal to x. My problem would be 7 to the x equals 95. Well, there is no pretty number that I can raise 7 to and get 95. So we have our change of base formula for that. That formula is that if you know log base b of a, you can type into your calculator log of a divided by log of b. You can also type it in as natural log a divided by natural log b and solve your problem from there. 23 through 28, you're working with 3 basic rules. Your first rule is that if you have multiplication in front of your log, to condense it, you pull it in and it becomes an exponent. So for example, here it would be 2 to the 3rd or 8. In the opposite direction, if you have a number as an exponent, you can pull it in front of your log. So this would be 3 log base 3 of x squared y to the 5th. Your next rule is that if you have addition between your logs, you can pull them together and multiply. So this would be multiplying the 8 by the x minus 4. Or in the opposite direction, I can pull these apart since they are multiplied and write them as addition. On this one, you would still need to move the 2 and the 5, so don't think you're done there. Your last rule is that if there is subtraction between 2 logs, you pull them together and divide. Or, like on number 27, if you have division within your log, you can pull it apart and subtract them. So again, make sure you're checking your answer keys to give yourself some hints. The big hint I will give you on number 28 is to rewrite that as an exponent. When you are working through your equations, remember that this is a major part of your test, so make sure you look at them. We had a few different types. These first ones, 29 through 32, are all the same type, where it is log equals log. You are going to start by making sure it is actually just one log on each side. So for example, on 31 and 32, you need to condense both sides of your equation. So what I would do, if I look at 32 to condense it, this 2 becomes an exponent. And these 2, since they're subtracted on the other side, I will divide. So it'll be log of 4 when I do 20 divided by 5. If you have log equals log, you know the things inside your logs have to be equal. So this is the problem that I would be solving. You can expand this, or you can figure out how to get rid of that squared. You can do it either way, but you will solve this, set it equal to 0 if necessary, and factor, and go from there. So anytime it is log equals log, condense it, and then go ahead and set the insides equal. On the next 2, these are where it is set up as a log equals a number. The first thing you want to do is isolate it. So for example, on 34, you would divide by 5. So I would have natural log of 2a minus 1 equals 3. On 33, it's already isolated. Then you need to get this out of the log, so you're going to rewrite it in exponential form. So e to the third equals 2a minus 1. And then you can evaluate your e to the third and solve that problem. The next 2 here, switch now to exponential equations. Oh, sorry, going back a little bit. On your log equations, make sure that you check your answers, because there are things logs can't be. You cannot plug 0 or a negative into a log. You can't have the whole parentheses be that, so do make sure to go back and check. Some of your answers will not work, and you have to know to cross those out. On exponentials, you don't have that problem because you can plug anything you want into an exponent. When you're working on ones like 35 and 36, I want to make these bases match since I have multiple exponents here, and I can rewrite these. So for example, 64 is 4 cubed. And now these have the same base, so I can set my exponents equal to each other. On number 36, you're going to rewrite both of those, but you will be able to do it. Ones like 37 through 40, you cannot rewrite. So I cannot rewrite 8 and 48 as the same base, or here I have so much more happening anyways. First thing you want to do is isolate whatever is written to a power. So I would add 11 and get 72. Divide by 2, 3 to the 4y equals 36. So then you are going to rewrite this now in log form, because again, that is going to isolate my variable, which is in my exponent currently. You will use your change of base to evaluate this and then solve it like normal. On the word problems, which is the bulk of the rest of the test, or the entirety of the rest of your review, you are making sure you know 2 different formulas. Your first one, that you will use much of the time, is your compound interest formula. Your second one, which you only use if they either give you the word continuously or they are talking about an infection, so like number 46, it says continuous growth rate and it's a flu virus. So on this one, we will use PERT. You are going to spend much of your time either plugging into these equations or solving them like we did on these previous equations up here, so like 29 through 40, which is part of why the solving is such a huge part of your test. Make sure that your A is your ending amount that you want to have or you're figuring out. P is your principal, so it's how much you paid, how much you deposited, whatever it is. R is your rate. Your N is how many times per unit it happens. Make sure you're looking at your percent. If it doesn't say, just assume it's a year. Most of them are going to be a year. And then your T is your time in, again, the same unit. So make sure everything agrees. All of it needs to be in years, which is how most of them will be, but do pay close attention to that just in case there's some that are not. What's important, make sure that you can solve. So on 46b, you're solving for time. So this one you are going to have to isolate your exponent and solve, again, just like on your previous equation ones. Make sure as you go through that you are checking your answers at the back. Remember also that I have extra practice of equations if you do need those.